Hi, welcome back to one more session on quadratic equation. In the last session, we were discussing about the methods of solving quadratic equations, and we have seen three methods. Three methods നമ്മൾ കണ്ടു അല്ലേ? അതൊക്കെയാണ് ഒന്നാമത്തെ factorization. Second one was completing the square, and the third one was മൂന്നാമത്തെ എന്തായിരുന്നു quadratic formula method. അല്ല, using that quadratic formula, ഒരു formula വന്നിട്ടുണ്ടായിരുന്നു. And we did excuse me, some questions on that particular in each type, and we discussed those. ഇനി നമുക്ക് ചർച്ച ചെയ്യാനുള്ളത് what is the nature of roots of a quadratic equation എന്നുള്ളതാണ്. അതായത് ഒരു quadratic equationൻ്റെ റൂട്ട്സിൻ്റെ സ്വഭാവം എന്താണ്, രണ്ടും ഈക്വൽ ആണോ, തുല്യമാണോ, വ്യത്യസ്തമാണോ, അതെങ്ങനെ റിയൽ ആണോ, റാഷണൽ ആണോ, ഇമാജിനറി ആണോ എന്നുള്ളതിനെ പറ്റിയൊക്കെ നമുക്ക് വേണമെങ്കിൽ ഒന്ന് ചർച്ച ചെയ്യാം. So let us consider a quadratic, the general formula. What was the general formula? The general formula was, or general equation was, ax square plus bx plus c is equal to 0. And we have the formula. What was that quadratic formula? X is equal to minus b plus or minus root of b square minus 4ac divided by 2a. Now there are different cases arising here based on the value of this part. What is this? B square minus 4 is known by a name, discriminant. What do you mean by discriminant? That discriminates because this value of this is going to make some changes in the nature of this root. Nature of this roots means whether they are same or different or positive or negative, irrational, I mean imaginary. What is imaginary? What do you mean by imaginary? Which is not real, we say it imaginary. Which is not real, we say imaginary. Becoming the president of America, it's not real, we say it's imaginary, we imagine about that. Similarly, numbers which are not real, we call it as imaginary numbers. Let us consider an example. X square minus 4x plus 4 equals 0. Here, what is a? A is equal to 1, b is equal to minus 4, and c is equal to 4. What is b square minus 4ac? B square minus 4ac is equal to minus 4 square minus 4 into 1 into 4. That is equal to 16 minus 16, and b square is equal to 0. Sorry, b square minus 4ac is equal to 0. I call the discriminant. We can call it as b, as a discriminant. Discriminant is equal to the value of the discriminant is 0. Value of the discriminant is 0 in this case. Okay, so now what are the solutions? Let us write the solution. X is equal to minus b plus or minus root of that discriminant by 2a. That is equal to minus of minus 4, that is 4, minus of b. Minus of b is already minus of minus 4, minus of minus 4, minus b plus or minus root of 0 divided by 2 into 1. That is equal to 4 divided by 2 into 1. That is equal to 2. That means what about the other part? There are 2, there should be 2, only 1. We are getting only 1. What about the other one? See, when this part is 0, plus 0 minus 0 doesn't matter. That means this roots or the solution of the equation are, or the roots of the equation are, x is equal to 2 and x is equal to 2. That means both of them are equal roots, coming it as equal roots. Let us take it another case. X square minus 2x plus 1 equal to 0. Because when you look at this, you can see there is another phenomena happening here. This is nothing but x minus 2 whole square is equal to 0. That is x minus 2 equal to 0, x is equal to 2. But when you are using the quadratic formula, we can see that the b square minus 4ac part is becoming as 0. Let us write one more example for that. The second example equation that I wrote is x square minus 2x plus 1 equal to 0. A is equal to 1, b is equal to minus 2, and c is equal to 1. 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 So what is b square minus 4ac? B square minus 4 is our discriminant. B square minus 4ac is equal to minus 2 whole square minus 4 into 1 into 1, or that is equal to 4 minus 4 is equal to 0 again. That means what happens here? That is the solution. What is the solution? Formula x is equal to minus b plus or minus root of b square minus 4ac divided by 2a. That is equal to minus of minus 2 plus or minus root 0 divided by 2. That is equal to 2 by 2 equal to 1. That means it is the solutions are x is equal to 1 and x is equal to 1. That means again the roots are repeated. So, we conclude that whenever discriminant, the value of discriminant, that is b square minus 4ac is equal to 0, the roots are what? Roots are always what? Equal. The roots are equal. So, we conclude that when b square minus 4ac is coming to be a 0, what happens? The roots of the quadratic equation are equal. So, that is our first case. That is first case. Case 1. When b square minus 4ac, b square minus 4ac, our discriminant, is equal to 0, what happens? Roots or solutions are what? Equal. Remember this. Let us put it in a box and carry. Okay. So, this is the box and will carry for this item number 1 or box number 1 or condition number 1, b square minus 4ac is equal to 0, the roots of a quadratic equation are equal. Now, let us consider another example or another quadratic equation. The quadratic equation is x square we will write another quadratic equation, x square minus 3x plus 2 equal to 0. This is an example that we discussed yesterday, I mean in the last session. In the previous session we have discussed this in as an example for factorization. You remember it or not? So, here a is equal to 1, b is equal to minus 3 and c is equal to 2. What is the discriminant, the nature? B square minus 4ac, that is equal to b square minus 4ac is equal to, that is minus 3 whole square minus 4 into 1 into 2, that is equal to 9 minus 8, that is equal to 1, which is greater than 0. The discriminant is greater than 0. Let us write down the equation and the solution, the quadratic formula. X is equal to minus b plus or minus root of b square minus 4ac divided by 2a, that is equal to the negative of minus 3 minus b minus of minus 3. So, it is equal to 3 plus or minus root of 1 divided by 2 into 1. 2 into 1, a value of a is equal to 1, 2 into 1. So, that is equal to 3 plus or minus root 1 is 1 divided by 2, that is equal to 4 by 2, or 4 by 2 means 3 plus 1 or 3 minus 1, that is 2 by 2. 2 value, I repeat, 3 plus 1 by 2, 3 plus 1, 4, 4 by 2 or 2 by 2, 2 comma 1. In short, we are getting two different values or distinct value. They are not equal. They are not equal. Roots are not equal. Instead, we are getting what? Distinct root. We are getting distinct root or unequal roots. So, this is the point that we have to remember. Let us consider one more example of that sort, same type. Let us consider one more example of same type. Okay, let us consider one more example. The example is x square minus 5x plus 7 plus 3 is equal to 0. That is better. X square minus 5x plus 3 is equal to 0. A is equal to 1, b is equal to minus 5 and c is equal to 3. B square minus 4ac, the discriminant value will be equal to minus 5 whole square minus 4 into 1 into 3, that is equal to 25 minus 4 3s 12. So, that is equal to 13. So, the solutions are minus b plus or minus root of the discriminant b square minus 4ac by 2a. So, this is equal to minus of minus, that will be 5 plus or minus, b is minus 5, minus of minus 5, minus b is equal to minus of minus 5 plus 5, plus or minus discriminant divided by 2. So, this is equal to 5 plus root 13 divided by 2, and 5 minus root 13 by 2. Anyway, we can see that they are not equal, they are different. Unfortunately, the values are coming to be irrational numbers. From entrance point of view, those who are preparing for MCQ, we need to know when do we have irrational roots and all. For others, doesn't matter. We need to know. In grade 10, we need to know whether they are equal. Roots are distinct or different. Distinct roots are coming. Okay, when does this happen? This happens when b square minus 4ac is greater than 0. b square minus 4ac is greater than 0. So we conclude, we make the second conclusion. What is the second conclusion? What is the second conclusion? That is the second box. Item number 2, the box number 2, we have a box. If b square minus 4ac is greater than 0, then we have distinct roots or different roots or unequal roots. Roots are unequal, or we can say that roots are unequal. Roots are unequal. So this is our second box to carry. Ready? Second box to carry. Roots are unequal. So we have seen these two cases. The first case was b square minus 4ac is equal to 0. In that case, equal roots, and roots are equal. And in case b square minus 4ac is greater than 0, we have distinct roots. Roots are unequal and they are different. We have two of them. Okay, now let us go for one more case. The last case is there. Last case. What will probably the case be? Okay, next case. Let us consider a quadratic equation. X square plus x plus 1 is equal to 0. A is equal to 1, b is equal to 1, c is equal to, all of them are 1. What is b square minus 4ac? That is equal to 1 square minus 4 into 1 into 1. That is equal to 1 minus 1, that is equal to minus 3. The value is less than 0. Let us see, let us solve it. What happens? X is equal to minus b plus or minus root of b square minus 4ac divided by 2a. That is equal to minus 1 plus or minus root of minus 3 divided by 2a. My God, what's coming here? Then the root of minus 3. Oh my God. What is this? Root of minus 3. Root of minus 3. What is this root of minus 3? Root of minus 3. Oh my, that is a big deal now. Root of minus 3. Root of minus 3. Root of minus 3. What to be done with that? Root of minus 3. My God. Not root of minus 3, minus 3. Root of a negative value. Square root of negative. What is that? Square root of a negative 1, what is that? It is not a real number. No real number is there. No real number is there. No, there is no real number whose root is negative. There is no real number. If you take a negative root of any negative number, it won't be a real number. So, root of a negative number cannot be a real number. And then what is that? If it is not real, then what is it? If it is not real, then what is it? It is imaginary number. It's not real number, imaginary. In short, what we conclude here is that that is in case if the roots are, that is the discriminant part. If the d part is, the discriminant part is less than 0, then we can say that the roots are not real. We can say that roots are not real. To put up one more example here. We will put one more example here. Consider any quadratic equation like x square plus 5x let us see, plus 8 is equal to 0. A is equal to 1, b is equal to 5 and c is equal to 8. B square minus 4ac is equal to, b square is 25 minus 4 into 1 into 8, that is 25 minus 32, and it is less than 0. When you look at the quadratic part, that will be minus, and the solution, my quadratic formula, minus b plus or minus root of b square minus 4ac divided by 2. Whatever may be the values that you substitute, you will be getting what? The discriminant part, it's a negative value. So, you cannot find the root of that negative value, and it is not what? Not real. I repeat, the roots are not real. The question is, when are they not real? When are they not real? It is not real. They are not real. When are they not real? When are they not real? They are not real when we have the third case, the third box. But the third box is b square minus 4ac is less than 0, then roots are what? Are not real. Roots are not real. So, in short, we have three cases. The first case was b square. Case 1 was b square minus 4ac is equal to 0. Equal roots, equal roots, roots were equal. And case 2 is b square minus 4ac greater than 0. We have distinct roots, and in case b square minus 4ac, the discriminant is less than 0. Roots are, or we can say, no real roots. No real roots. So, this is the conclusion that we make here. We can just try with our worksheet. Before getting the questions, we'll just show you. It is the conditions are given here. B square minus 4ac is called the discriminant of the quadratic equation. If b square minus 4ac is greater than 0, I just reverse the order. Greater than 0, positive. The roots are distinct. Two distinct real roots. We have two of them, distinct and real roots. And b square minus 4ac is equal to 0, then the roots are equal. Here, unequal. Here, in the third case, b square minus 4ac is less than 0, no real roots. So, with that, we will be using with this knowledge, we will be attempting few questions based on this particular topic, in order just to let us make this little more clear. Okay, what are the questions given here? There will be a sure board question from this part. Be careful with this part. You can get direct straight question from this. In each of the following, determine whether the quadratic equation have equal roots, and if so, find the roots. If so, find the roots. Let us go for if they have, whether the given quadratic have real roots, not equal roots, have real roots. So, the question is specific. Whether the question have real roots. When does they have real roots? They have real roots when? What is the condition? There was a condition. What was the condition given? The condition is nothing but they have real roots. When do they have real roots? They have real roots when b square minus 4ac is greater than 0. You have real and distinct and real. Okay. If b square minus 4ac is equal to 0, then also, but the problem is equal, then also we have real roots. When do we don't get real roots? The condition is b square minus 4ac is less than 0, then no real roots. So, here we are worried about whether it is coming less than 0. Okay, so let us take one by one. Let us take one by one and see how things are coming. We will take one question here. Question number 1. 3x square plus 2 root 5x minus 5 is equal to 0. Equal to 0. So, a is equal to 3, b is equal to 2 root 5, c is equal to minus 5. I said board exam will get to sugar not from this part, but from question number 3. Please be aware of that. Question number 3, I mean question number 3, not exact, of course from this part, but not from this particular two questions. Question number 1 and question number 2, you won't be getting it. Okay. So, b square minus 4ac is equal to discriminant. The discriminant d is equal to, that is 2 root 5 whole square minus 4 into a into, this is equal to 4 5 is 20 plus 4 3 is 12, 60. This is equal to 80. I think in the previous session we have solved this. I think so. In the last session we have solved this using quadratic. Here b square minus 4ac is greater than 0. So what is the nature? The roots are real and distinct. Roots are real and distinct. In this case we have real roots. How can we find the roots? How can we find the use? Use the quadratic formula. X is equal to minus b plus or minus root of b square minus 4ac divided by 2a. In the last session we have solved this particular question as such. The solution is available there. Now question number 2. Question number 2, or we will go for question number D, not 2, question number D. The question number D. We will go for question number D. Okay. Question number D. Question number D, that is root 3 x square minus 2 root 2x minus 2 root 3 is equal to 0. A is equal to root 3, B is equal to 2 root 2 and C is equal to minus 2 root 3. B square minus 4AC, that is equal to 2 root 2 whole square minus 4 into root 3 into minus 2 root 3. So this is equal to 4 to 8 and root 3 into root 3 will be 3. So it will be negative of negative plus 4 into 3 into 2, 8 plus 24, that is equal to 32. It is greater than 0. So roots are, I have real roots. Roots are real. Roots are real or real roots. And what else do we know? They are distinct. How do we find it? X is equal to minus b plus or minus root of b square minus, or you can use any method, completing the square or splitting middle term, 2a, that is equal to minus b, that is 2 root 2. So here there is a small problem, I forgot this minus, be careful with that. Here also, but the value won't be changing. Here the value won't be changing, minus 2 per square. So plus or minus root of, that is root of 32 divided by 2 into a is equal to root 3. So this comes as 2 root 2 plus or minus root 32 is again, that is equal to 16 into 2. So 4 root 2 plus or minus 4 root 2 divided by 2 root 3. From this we will be getting two different values. The different values are, which are the different values? The different values are, one is 6 root 2 divided by 2 root 3. 6 4 plus 4 root 2 plus 2 root 2, that is 6 root 2 divided by 2 root 2. 2 will go 3 times, that is 3 root 2 divided by root 3. Root 3 will go in 3 root 3 times. So it is equal to root 3 into root 2, that is equal to root 6. Similarly, you will get 2 root 2 minus 4 root 2 divided by 2 root 3. So you will be getting minus 2 root 2 divided by 2 root 3. You will cancel this as well, that will be minus 2 by 3. You will be getting two values from this. Now similarly, we have more questions there. We won't be doing this. This is again the repetition of the find the nature of roots. If I repeat, if suppose in one case, let us do this question number B for you. I will do B again. One more question. X square plus x plus 1. What is a? What are a, b, c? A is equal to 1, b is equal to 1, c is equal to 1. B square minus 4ac. When you do that, you can see that 1 minus 4, it will be negative 3 less than 0. What is the nature of roots? No real roots. No real roots. The roots are in fact imaginary or not real. Not real. We can conclude that not real. Now let us go to the next question, question number 3. This is very important. Find the value of k for which for which the roots are real and equal in each of the following. They say the roots are real and equal. What should be the condition? They say the roots are real and equal. Let us take question number, that is 3, question number 3a. Roots are real and unequal. What is that? Kx square plus 4x plus 1 equal to 0. This is the first question coming there. What are a, b, c? A, in place of a is equal to k, b is equal to 4 and c is equal to 1. What is b square minus 4ac? That is equal to 4 square minus 4 into k into 1. That is 16 minus 4k. This is what is given. I mean, what we get. What does the question say? That roots are equal. What do you mean by equal roots? B square minus 4ac is equal to 0. Why? Since roots are equal. Roots are equal. B square minus 4ac, that means 16 minus 4k is equal to 0, or 4k equal to 16, or k is equal to 16 by 4. The value is equal to 4. Hence, the value is equal to 4. Okay, we will take one more. Option question number B. What does the B question number B says? What is question number? Question number, this is question number question B. Question number B. Question B. Kx square minus 2 root 5x plus 4 equal to 0. What is the nature of the roots? What are the nature? I mean, what is the value of k? So that again, the question is what? Roots are equal. It's mentioned that the roots are equal. What is the value of k? K is equal to, that's what is in place of a? A is equal to k, b is equal to minus 2 root 5 and c is equal to 4. So here, given that, what is given? Given what? That roots are equal. Roots are equal. What does that mean? That means b square minus 4ac should be equal to what? Should be equal to 0. B square minus 4ac should be equal to 0. If b square minus 4ac is equal to 0, I mean, then what happens? Minus 2 root 5 whole square minus 4 into k into 4 is equal to 0. That means 2. This will be 5, 5 fours, 20 minus 16k is equal to 0. That means 16k is equal to 20, or k is equal to 20 by 16. That means 4 will go 5 by 4. 5 by 4 is the answer. We will take one more question from this. Let us take a better, little more tougher question. We will take this question. Question E. We will take this question. This is question E. Question E. Question E. Kx square minus 2 into 2k minus 1x plus 4. Given that roots are equal. A is equal to k square, b is equal to, be careful with that, minus 2 into 2k minus 1, and c is equal to 4. B square minus 4ac is equal to 0. What is the reason why? Since roots are, what is the reason? Roots are equal. Given, you should write like that, roots are equal. So b square minus 4ac is equal to 0. Now let us use that minus 2 into 2k minus 1. This whole square minus 4 into 4 is equal to 0. 4 into 2k minus 1 whole square. Where do I get 4? Minus 2 whole square minus 16k square is equal to 0. 16k square is equal to 0. So, this is equal to 4 into this part when I am expanding a minus b whole square, 4k square minus 2 to 4k plus 1 minus 16k square is equal to 0. That is 16k square minus 16k, 4 minus 4 plus 4 minus 16k square is equal to 0. That means minus 16k is equal to minus 4, or k is equal to minus 4 by minus 16, or that is equal to 1 by 4. So, that is how we do these questions. So, that is a condition is applied in that. Now, we will be attempting one more question. If you want, you can do one more question. I will do one more from this. Let me take a little more tough question if available. Yes, I will take this question. This is from homework part. Homework question, that is homework 4.4 question number 2C. This is the question, that is homework 2C, 4.4 2C. Find the value of k, again find the value of k for which the roots are equal, real and equal in each of the following, and that question number C. So, a is equal to what is in place of a? A is equal to k plus 1 whole, and b is equal to minus 2 into k minus 1, and c is equal to 1. So, given, what is given? Roots are equal. Therefore, what does that contain? B square minus 4 AC is equal to 0. B square minus 4 AC equal to 0. So, that means B square minus 4 AC is equal to 0 means B square minus 2 into k minus 1 whole square minus 4 into k plus 1 into 1 is equal to 0. That is 4 into k minus 1 whole square minus 4 into k plus 1 b square minus 4 into 1 is equal to 0. 4 into k square minus 2k plus 1 minus 4k minus 4 equal to 0. 4k square minus 8k plus 4 minus 4k minus 4 equal to 0. Minus 4 plus 4 cancel. 4k square minus 12k is equal to 0, because a minus 8k minus 4k. Here what is common? 4k is common into k minus 3 is equal to 0. So, here 4k into k taken common outside, k minus 3 is equal to 0. That means product of two things is 0, product of two things. So, 4k is equal to 0 or k minus 3 equal to 0, either of them can be 0. That means, in this case either k equal to 0 or k is equal to 3. There are two values that can be taken for k, but we have to be very careful in such things. Whenever k is equal to 0, be careful. Danger, there is a danger. There is a danger coming, danger, big danger. What is the date? In suppose the equation given us, I will write the danger part using red color. because it's really dangerous. I mean, it's really dangerous. Suppose that k part is 0, k part is coming to be 0. Suppose the equation is coming as, instead of k plus, I am rewriting this equation here, instead of this is the danger, okay, danger, instead of k plus 1, suppose the equation is like this. You have to be very careful. There's a trick, I mean, it's not a trick, there's a trap actually. It's a trap there. What is the trap? Suppose you are getting the value as k is equal to 0. Does it, can I put over here? What happens in a quadratic equation? Ax square plus bx plus c is equal to 0. A cannot be equal to 0. So, you have to be very careful with this particular case. Here there is no issue. Why there is no issue? Here there is k plus 1. So, even if you put k is equal to 0, there is no issue. So, be careful in those cases. That is, there is a, suppose the situation is like this, that is, suppose you have an equation, like this, k x square plus 2k something, 2k plus 1 or anything into x plus 3k is equal to 0 as real roots, and you are getting k is equal to 0. Be careful, this place cannot be 0, coefficient of x square cannot be 0. In this case, I am coming back, here k can be 0, because when you put k is equal to 0 over here, k is equal to 0 over here, doesn't matter at all. Why? Doesn't matter at all. Why? Because plus 1 is there, this part will be 1x square. So, there is no issue with that. So, this is what we have discussed, that is the nature of roots of quadratic equation. This is a 100%, that means a sure question. You can expect a sure question from this part, almost sure like the thing, because most probably questions are asked from this. So, be very careful with this part, learn it properly. So, I repeat it, what are the three conditions that can arise? The three conditions that can arise are, first one, b square minus 4ac is equal to 0, roots are equal, and here case 2, b square minus 4ac greater than 0, that is positive, roots are real and what? Distinct. And the last third one, b square minus 4ac less than 0, that is no real roots. Three cases you have to be careful with. You have to be careful with three cases. Okay, thank you.